Java, what we're going to do here in this session is we're going to do something a little different. And that is, we're going to run this quiz style. So you decide what to talk. How about that? It's more fun for you to tell me what to talk than me telling you what I'm going to talk, right? We're going to talk about things like objects, collections, Java 5, syntax sugar, and concurrency. So you decide what you want to talk about, and when you decide what topic you want to talk about, you make an effort to answer, and if you answer, I'll throw a candy somewhere near you. And it usually hits the person next to you, which really makes it well, because the minute you answer a question, the person next to you becomes very alert. So I'm ready. Concurrency for 1,000. Who said that? Oh, come on. You got to sit up all the way over there. All right. Ready, everybody next to him? Oh! Now you know why they threw me out of the country. There you go. Very close. That's all I can do. What did you say, by the way? Concurrency for 1,000, he said, right? All right, let's do it. So what we have here, this is an easy one. What we have here is a count, and then within the count, we have a get count and a set count, and then we have increments several times, as you can see the function name, right? And then it has a thread. Within the thread, it has a run. Within the run, it keeps counting. What's wrong with this code? Oh, they're synchronized on the top. You see that? Synchronize get count and synchronize set count. Who said there's no synchronize? Nobody said it? I just heard it. You said, give me back my candy. No, you're right. That synchronize is not enough, right? So what's wrong here? What's wrong here is, who is that? Raise your hand if we should vote him out of the island. Okay. So no interrupt exceptions, no. So this get count is going to lock, get the value of the counter, and what is it going to do? Release the lock. And then it's going to come back and request the lock one more time. And between the time it released the lock and gets the lock, another thread could come in. Right? So even though we had synchronized over there in the code, this is not thread safe. So how do we fix it? What was that? You can put synchronize around these two blocks of code, right? You could do that, right? All right, I tried. That's one answer. What else? You create a dummy object, you're saying? I think this part of the room is troublemakers. How about atomic integer? Huh? Atomic semaphore? Gosh. Okay. Atomic integer, right? So what we could do is we could do this. We could simply say here, atomic integer count, right? Equals new atomic integer. So what's the benefit here? The benefit here is that because it's an atomic integer, it will take care of the locks. So how do you increment the lock or change its value? You call one method on it. You will say count dot increment and get. That becomes an atomic operation. So you don't have this problem of acquiring the log, getting the value, releasing it, oops, somebody else went and modified it. So Java util concurrent API is something worth looking at that solves quite a bit of problems. That's one answer. The other answer is to avoid the problem at its root, which is the problem of mutability. If you make things mutable, then you have to protect it from multiple threads accessing it. Alternately, you could make these things immutable, and if they are immutable, there is no problem with multiple threads accessing it. They won't collide with each other. But then you say, but how do I still keep track of the count? Well, you could make it mutable but protect it, don't let multiple threads access it. But then there is something called an actor-based model, not supported in Java at this moment, but that's where languages like Scala provides you, actor-based model, and you basically do message passing, and there is no issue of concurrency or that gets handled. Writing concurrent code in Java is extremely hard. How many of you have written multi-threaded code in Java? Quite a few of you. How many of you think those code work correctly? 2 people, 3 people, 4 people. They think it works correctly. Writing multi-threaded code in Java is like working with a mother-in-law. It's waiting for you to fail. So it's very hard to get it right. Okay, so that's one way to think about it. What's the next thing you want to talk about? What was that? Object for what? Object for 1,000. All right, we have an equipment class, and the equipment has an ID, and I want a unique ID, so I increment it. And then I have a get ID which returns it. I have a clone method that does super.clone. What's wrong with this code? That's right, you lose the uniqueness of the ID, right? And you still have to sit there and answer the question. All right, I'm going to try. Should we wait for him to sit down? All right. Oh! All right. That's too far. Next time we'll find a smaller room. Okay, so yeah, he is right, absolutely right. Let's spend some time on this. Let's say we have the equipment and we want the uniqueness of these equipment. That's what we're trying to do. So let's give it a shot. So I have this class equipment, right? So class equipment. And I want this to be an ID within this class. So I'm going to say private int ID. And I want this to be unique ID. So private static int unique ID, right? And in the constructor of the equipment, I'm going to say ID equals unique ID plus plus, increment the value. And I want to write the toString method. So within the toString method, what am I going to do? I'm going to return the ID. So let's just say ID plus, let's return the hash code just to kind of get a feel for it. So I got the hash code I'm returning as well. I want to make a copy of this object. That's what I'm trying to do, right? So what am I going to do here to make a copy of the object? I'm going to create an equipment. Let's call it eq1 equals new equipment. So now what I'm going to do here is I'm going to say, I want to make a copy. Well, let's print this out. So here's my equipment. I want to print it out. And then what I want to do now is to make a copy of this. So equipment2, we'll say eq2 equals equipment. And I want to make a copy of this, and we can use the clone method for it. So eq1.clone, there we go. But of course, for this to work, I need to implement some interface. What is it? That's right. I can't throw candy at you for that. Okay. Implements clonable, right? How many methods does clonable have? 0 methods. It's a tagging interface, right? That's correct. So I'm going to implement the clone method. And in the clone method, I just simply call clone.super.clone, right? That's what I did here. So what I want to do here at this point, we got the clonable interface implemented. And it wants us to support the exception. We'll make it happy. There we go. So go ahead and run this code. Oh, I need to print out the equipment2, right? So output eq2, and go ahead and run this. And notice, as he rightly pointed out, the ID for both of them is exactly the same. How did that happen? What's that? Actually, well, it could be. But it didn't do a shallow copy. What it actually did is, remember when you create an object, we go through a construction. But clone says, I'm special. I'm not going to go through this constructor. I'm going to perform a mem copy. So it literally did a mem copy. That's what it did. Can I throw the candy at you? Yeah. All right. Whoa. No, stay there. I'm going to try to throw this. I'm really bad at throwing, but I cannot compete with you. I'm really bad thrower. I'm sure you catch really well. Okay, we tried. All right. Okay, so mem copy, right? It performs a mem copy. So how do we fix it? The problem is with the clone method. Let's fix the clone method. So how do we fix the clone method? Here's an idea. How about this? Let's go to the method, clone method. We'll make a copy first. So we're going to say equipment, the equipment, and equals equipment, super.clone. And then once we create this clone, we'll return this equipment that we created. So we could say the equipment, right? But before we return it, we're going to say the equipment.id equals unique ID plus plus. Execute the code. Seems reasonable, right? But here's an idea. If ID is so unique, wouldn't you want it to be final? You don't want to be changing it, right? Because once you create the ID, why would you want to change it? So I marked it as final. Hey, but what happened? Look at line number 17. That doesn't want to compile anymore. Why is that? It says final cannot be modified. Final variables, fields can be modified in the constructor and in the initializer. You cannot change it in other methods. Copying to do. So now if I want to use this, I'm going to simply go over here and say, hey, I don't want to clone this after all. There's no clone method here. I'm going to say new equipment, and then I'm going to pass this equipment, right? That's as simple as that. I could do this. Go ahead and run this code. My fault. So go ahead and run this code, and what happened? Hey, look, it works. So should we use a copy constructor then? I'm not going to ask her. Obviously, she's biased. She says yes. But what do you think? Yeah. You got more friends here. So let's consider this for a second. If a couple of weeks goes by, and I decide to create a class called better equipment, which extends from equipment, right? So there's inheritance hierarchy here, right? And I create the constructor for better equipment. I also create the constructor for the equipment, copy constructor for the better equipment. So I got those two classes. Is it legal to do this? Is line number 39 valid? Yes, it is valid. Because of inheritance, I can assign an instance of better equipment to the equipment, right? But I didn't change line number 42. I don't have to. Why? Because that could have been in another function. I could be passing this equipment to this other function, and the function says, well, thank you. You gave me an equipment reference. I'm going to create an object of it. Now when we run this code, what happens? Well, we don't see anything right now, but let's go fix this for a second. I go to this method and say plus, and I'm going to get the class .getName for this. And when I execute this code, surprise. While the class that we created, the instance we created was a better equipment, when we made the copy, we ended up with an equipment. Should I use a copy constructor? I want to extend better equipment. That is my problem here, right? I'm not in a composition here. So should I use a copy constructor still? Should I use a copy constructor still? Copy constructor doesn't work, right? And clone doesn't work. What do we do about it? So the reason copy constructor doesn't work is it's not extensible. Because the word new is not polymorphic. You said new equipment. What do you normally do? Polymorphism, you call a function on an object. Here, you're not calling a function on an object. You said new something. That's not polymorphic, right? That's why copy constructors are bad. Well, cloning is a good idea. But why doesn't clone work? The reason clone doesn't work is because clone cannot deal with final fields. Well, it turns out she's actually right. I was a comma, not a full stop. However, next time, just wait a little bit. Could you restrain here, please, next time? Okay, man. All right. So, it turns out she's almost right. And the problem is the copy constructor is not polymorphic. The problem is not the problem with clone. The problem is the way clone is implemented in Java. So we could use the combination of these and fix it. Notice what I'm going to do. I am not going to use the copy constructor here. Not there. I'm going to fix it over here. Let's go back here. I'm going to use the clone method. So notice I go back here and say equipment, and I'm going to say equipment1.clone, just like we did before, right? I'm going to go back to the class. I'm going to implement clonable. No problem. However, I'm going to make the copy constructor of my class protected. When you make it protected, you cannot access it from outside. So if you're using my class, you will not be able to call the copy constructor on my class. You are forced to use the clone method. Fair enough? Then what I'm going to do is in the derived class, I'm going to make the copy constructor protected as well. But then what I will do is I'll go to the clone method, and in the clone method, rather than doing something as complex as this, I'm going to remove this and simply say return new equipment this. Notice how I'm using the copy constructor within the clone method. And then what I'm going to do is to go to the derived class, and I'm going to override the clone method here one more time. And here I'm going to return new, better equipment this. So I'm using the copy constructor of the derived class in here. Notice how we tricked it to be polymorphic. Because the clone is polymorphic, but the implementation of clone in Java didn't work, but it can throw it away. And we draw this into here polymorphically and say, okay, now that you're in the base class, create an instance of base, or polymorphically, now that you're in the derived class, create an instance of derived. So now if I go run this code, let's see what happens. If I go run this code this time, we got a proper copy of this object, right? So that is an example of how we could make the code polymorphic. Questions? What do you think? Make sense? So it turns out that a better way to make copies of objects is to mix cloning and copy construction together. Clone itself doesn't work. Copy constructor itself is not polymorphic, but a good combination of them put together is a much better way to write this code. All right, what's the next thing you want to talk about? Java 5? How many? 500. Who said that? All right. Yes. Okay, so Java 5 for 500. Let's do it. What's wrong with this code? Button.add mouse listener, new mouse adapter, public void, mouse clicked, mouse event. What do you think is wrong with this code? That's not the problem. But you can still have the candy. Who said that? Oh. I'm going to try to throw towards you, but I'm sure it's going to hit somebody else. Oh! Woohoo! All right. That's not the problem. The problem is, this is going to frustrate you. What was that? Who said that? That's the answer. Yeah. Mouse clicked is spelled wrong. You say, what's the big deal? The big deal is wasted time. This actually happened on a project, not with mouse clicked. I was sitting down with the programmer. He overrides the method, and it doesn't work. And he's sitting there scratching his head for 10 minutes. Why wouldn't this work? Why wouldn't this work? And he calls me over. I look at it. I don't understand why it doesn't work. And then suddenly we both are like, maybe there's a bug in Java. Right? Stupid things like that, we think about it. So how do you fix this problem? Who said override? Who said override? Thank you. Yes. That is the purpose of the override keyword, annotation in Java. So what does override do? Excuse me. What was that? It checks at compile time. That's right. So override, I'm going to throw this towards you. There we go. Cool. At compile time, all right. So at compile time, what does it do? At compile time, oh. You okay? All right. So at compile time, what does it do? It says, hey, wait a second, are you really overriding that method? And it says, wait, there is no method in the base class with that case. Remember, Java is case sensitive. And so, no, you're not overriding, and it'll become a compile time error. The only thing I wish is, I wish override is required in Java rather than being optional, right? But unfortunately, it's only optional. But then there's the language called Scala, where override is required. You will not be able to override a function without putting override. Is there another language where override is required? C#. That's right. In C#, override is required. So marginally, it is a better language for that reason. That's correct. Excellent. What's the next thing you want to talk about? Collection for 1,000. Do we have collection for 1,000? Yeah, we do. Okay. Oh, good catch. We're getting better at this. All right. So collection for 1,000. Hey, we already talked about this earlier in a session, so we'll skip that. Give me back my candy. Okay. What was the next one? What was the next one you want to talk about? What was that? Did you say sockets? I'm like, hey, you're writing a new talk. All right, syntax sugar for 500. That's what we do. Syntax sugar for 500. Boo. What's wrong with this code? Who said syntax sugar for 500? Oh, there we go. What's wrong with that code? Come on, you can do it. Result is not what? Who said that? Woohoo! Null pointer exception. Did you catch it? It's a null pointer exception. How is that? Look at this. We're sending an integer. Well, actually, there's more than one problem. One problem is you're sending the integer value, and what does it do? It says if value %2. What's going to happen right there? Auto unboxing. It's going to unbox it, right? Because value %2 is an operation on int, not on integer. So very quietly it performs an unboxing. And then what does it do? And then it says if it is, result is value times value. But if it is not even, the result is still null. So what that function returns to you is a null. But the poor compiler doesn't know it. So what does the compiler do? In the main you say square if even, and it sets that to result, and that is auto unboxing. Unboxing on a null is undefined. So this will result in a runtime null pointer exception. So while autoboxing is very convenient, it makes the code unsafe. You got to put more tests around it to protect it. So very dangerous to run this code, right? All right, cool. What's the next thing you want to talk about? I heard concurrency here. Collections for what? Collections for 500. Let's do that. What's wrong with this code? Who said collections for 500? There we go. Oh. Too far away, sorry. Who said array store exception? All right, cool. And why do you know that? And what did we assign? By the way, that is not 11. That is 1L. That's 1L. Is it a good idea to write code like that? The only time you use lowercase l to specify long is if you hate the people you work with. Right? Because they look at this code and they can never find out. So you're absolutely right. What happened here is, you took this collection of integers. Oh, by the way, I was saying this morning that arrays are evil because, notice what we did here. We took an array of integer and assigned it to an array of objects. That's evil. Why did they do it? Because for design convenience. Oh, now we can call any function that works with arrays with any other collections, right? So it's a backdoor. That's why they did this. But anyway, value 0 is expecting to have an integer, and you stuffed a long into it. But because value 0 is an object array, the compiler cannot catch this problem. So once again you get a runtime exception, and this time what do you get? Array store exception. This is a good time to stop and think about something. In all the examples I showed you so far, the code compiled. In all the examples I showed you so far, the code has a runtime exceptions. The point I'm making is, Java is really not safe. We just think it is safe. Right? It's just a touchy feeling. Oh, it is safe because we think so. But it really is not. You see so many ways that we can, fall through the cracks. That happens. Okay. Let's go to the next one. So the next one here, which one do you want to? Object for 500. So I got a file writer, and I got a sample throws exception, and I create an object of file writer. I have the finalize method where I close, the info where I write some stuff to it. So here in the main, I create a new sample, and I call object.info test. When I open the file, whatever the file name is, I don't remember. What will I, output.txt, what will I see? It'll be blank. Who wanted this question, by the way? All right, there you go. Throw that towards her. It'll be blank. Who said blank? Why would it be blank?
The close isn't finalized, not sure to be executed.
The finalize, chances are the finalize will never get called. There's only one word to explain the word finalize in Java. In fact, they should have renamed it as evil. Why? A, finalize may never get called. But it's even worse than that. When do you think finalize potentially could get called? During garbage collection. During garbage collection, why does it get called during garbage collection? Why is the garbage collector running? Because it's low on memory. So the garbage collector says, oh my God, I need some memory. I'm going to garbage collect. It comes to finalize, and it says, I got to run this stuff. I cannot do it now. I have to postpone this. So I'll put this in the finalize queue. I'll get back to you. And goes away. And when it really needs memory, you cannot give it. Right? Finalize is a fundamental design flaw. You say, Venkat, is there something worse than finalize? And I think there is. That's when Microsoft went right through the wall and did that in C#. It's like, duh, what were you thinking? And they implemented dispose in the same way, right? It makes no sense because when the garbage has to be collected, you want it to be predictable. So what's the moral of the story? The moral of the story is twofold. The first one is never use finalize. You must call the close method yourself to release the resources. So here's an example. See if this makes sense. I'm going to create an object of this, whatever that object is, sample, right? So I'm going to say here, sample equals new sample. This sample is the object you saw over there. Sample dot info, and I'm going to call some, message. When I'm done, I'm going to say sample.close. This is a protocol you want to use, right? Now, what do you think of that idea? Is it good, bad, or ugly? What do you think? Is it a problem? What is the problem? What's the problem? That's right. If info threw an exception, the close never gets called, right? That's absolutely right. Good. So what do you have to do to fix it? You put in a try and finally block. So here is the way you would write the code, right? You would say sample, and then you would say try, and then you would say finally, like that. The whole thing has to be in another try, you're saying? Oh, within the finally, you got to put try catch for the I/O. Yeah, that's even worse. Right? That only gets bloated, right? Absolutely, you're right. Yep.
The catch is I don't know what to do with the catch.
When you said C# had the dispose method,
Right.
I was trying to understand whether C# design exactly is talking of Java.
To a certain extent it is, but then they improved on it. So I have to say they're a little notch better, but in that area they messed up the same way. Yep, please.
Isn't it bad practice to not have catch because you never know what went wrong?
Oh, no. Catch is a bad idea. Because if you don't know what to do with it, you want the caller to handle it. The worst thing to do is to catch and do nothing.
No, probably you could rethrow it back again.
Why would you? It's like the guy is running on fire. And you say, excuse me, stop. What? Why are you running? Because it's on fire. Okay, run now. Right? Step out of the way, right? Why would you catch and rethrow? Step out and say, you know what, it's your problem, keep running, I can't help you, right? That's what I do, right? I cannot help people. I don't hurt them. If somebody's running, I step out of the way. It's like, no, don't interfere, right? Yes.
This doesn't apply. A typical scenario of closing a connection, database connection.
Yes.
If I'm not able to close, and that throws an exception,
Yes.
there's no point I send that exception to the other layer.
I'm waiting, continue, I'm listening.
So one connection gone from the pool.
Here's the problem.
What does anybody do if the close fails?
So what do you do if the close fails? It doesn't matter what I do. What it really matters is this. I don't want applications to fail quietly. When applications fail quietly, what happens? Your support cost increases. Your customer calls you and says, your application doesn't work. Really? What did you do? Nothing. What does it say? Nothing. Do you see error message? No. Wasted time for your company, right? I want my applications to blow up, make a huge noise. Then we can go find and fix it. So the thing is, if you don't know how to handle it, propagate it in a place where it can be visible. The least is maybe to log it at least, right?
Logging is right, but logging is not really handling the state.
Oh, it is not, but at least you're making it visible in other means. I'm not a fan of logging myself, but that's the least. Or propagate it up and say, hey, at some level, maybe you're a UI level, maybe you cannot handle it, but at least play a sad music and display this, right? So people can know at least something went wrong, right? But never to suppress the exception and say, oh, nothing happened, when something has really gone wrong. Okay, coming back to this, you said there's probably more try and finally that's needed. That's correct. What do you think? Is that simple code now, or is it kind of smelly now?
Can have one indicator which will show the state of that object, whether it is already closed or not.
I'm not trying to fix that mess at all. I'm just saying, is the code we wrote so far pretty nice, or is it smelly? It's pretty smelly, right? Could you escort her out? What's the policy for people in being here, right? We have the right to throw people out, right? Man, I like her. That's good. Okay. So that's pretty smelly, right? So If you ask me to do it, I'll forget it half the time. This requires something I don't have. That's called discipline. That's so hard to come by. So what do? Well, there are other ways to fix it, but that is even more complex. But here is a good news for you. The good news is partly a good news, not fully a good news, and you can't do this today, but eventually you will be able to do it, is this. And ma'am, I removed that. Okay. So you say try sample equals new sample. And then what do? Sample.info, whatever methods you want to call, message. That's it. Obviously, that code doesn't compile right now. That's because that's a feature in Java 7, which is going to get shipped sometime in September, I think. So in Java 7, this is called ARM, Automatic Resource Management. And what they're going to do with Automatic Resource Management is that any object that implements an interface called closable. So if sample implements closable, you can put that in the try block as you see there. You don't need to write the finally. The finally is already written for you by the compiler behind the scenes. And as a result, it'll get cleaned up for you automatically. So that reduces the amount of code you have to write. You could even say that sample equals new sample, comma, something else equals something else, and then you can have more than one. Yes, please.
So what if that is the real closing code should go to sample as some method defined by the interface?
They will generate the try and finally for you. That's all they do. Rather than you writing all that craft, they're going to do it for you. That's all. There's no magic. It just reduces the code noise.
Closable is a marker interface?
No, it's not. The closable is an interface that has the close method. And you would have to implement the close method in that case. If the exception occurs, you still have to put the catch block. But the finally is not needed, right? But the point is, a lot of these cases, you don't care to handle the exception. You let it propagate, right? And that's the case where this becomes less noisy. Mm-hmm.
Isn't that very API-driven approach?
It is, but what else do you do, right? That's what C# did by using the using keyword. So finally, Java is catching up to it. Yes? Yes. Oh, you do. No, you do. Because the exception that was thrown propagates until you catch it. I don't care to have it here because I cannot do anything. Right? Right? It doesn't. So that is how you complicate applications. You want to step away and let the context propagate where it makes sense. That is why you have to don't follow patterns for the sake of following patterns. It's got to make clear sense, right? Right. Correct. Only when it's only when it's needed. You don't. You don't. We write way too much code than we really need. This is the way we complicate applications, and suddenly you need 27 people to maintain your code. There's no reason to do any of that. Keep it simple. Don't put things that are not needed, right? Let it emerge out. Hey, I need this information. Go build that in. Don't start propagating things all over. Then you have bloated code, and the more code you write, the more bugs you have. There's no reason to do that. If you only have a resource to clean up, not otherwise.
Every connection, every file writer, or every input stream, output stream has to be a closable.
You already had, right? It's just that you did not call it closable, but you already had a close method because finalize is broken. So you have just streamlined what you already had, that's all. You did not do any more work, you just streamlined this, that's all. Right? So you're making it more explicit rather than being implicit. That's all you've done. You didn't really introduce complexity more than you had it in the first place. So that is the benefit, is that you didn't increase the complexity. All right. What's the next thing you want to talk about? Concurrency for 500. Actually, I'm going to skip this. Let's do a concurrency for 100. What's wrong with this code? So I've got a static Boolean done, and I have the main. Within the main, I create a thread. Actually, I should show you the full code. That's even more fun. Let's pull up the real code and play with this. So here's my real code. So this is somewhere here. There we go. So here is the main code. Oops. So what do I have? Notice that I have a done as a Boolean. In the main, I create a thread. Within the thread, I say while done is false, keep incrementing the value of I. When you get out of the loop, say done is, print out done. Start at the thread, sleep for 2 seconds, and I set the done to true. Thread has been started right there. You're in a static context in both cases. You're saying it within the run. Int will go exceed range. We're not using it anyway, so big deal. What was that? Why? That's correct. So here is a problem. Very good point. Let's go try this. So I'm going to run this code, right? So I'm going to run this code. Here we are. Oops. So I'm on the Mac over here. So here's my sample class, Java sample. This is exercise, so got one up. Bless you. So here's my exercise dot sample, right? So I'm running the code. It worked. Right? It said done. Now I'm going to redo this. But this time, I'm running it without the 32. I did not recompile the code. I did not change the code. It's the same bytecode I'm running this time. Did it finish? It's been 2 seconds, right? It will never finish. How much time do we have? So what happened? What happened here is, your bytecode is sitting here. There are 2 compilers in Java. What are those? Our good old Java C, and then the JIT compiler. So what happened is, when you run it in D32, by the way, if you're on Windows, you can run Java. It will behave like the first one. But if on Windows you say Java minus server, it would behave differently. Because the JIT compiler it uses in the server mode versus client mode is different. In the client mode, it doesn't do optimization. In the server mode, it does. In the server mode, it says, oh dear, this variable is here, and it doesn't change in this thread, so I'm going to do you a favor. That's what the JIT compiler says. And the favor it does is, it takes the while loop and removes the done to outside, and changes the done while true. So this never sees. This is a problem of visibility. And one way to fix the problem of visibility is to use synchronize. But that's more of a side effect. But in this particular case, as he rightly pointed out, what you really want to do is to mark it volatile. So if I go back here and say volatile, So what does volatile do? Volatile says, hey, JIT compiler, don't be smart. I know a few things that you don't see. And what volatile says is, when you access this variable, do not get this variable from your register. Do not get this variable from your cache. Go all the way down and get this from the memory each time. And this is even more critical in a multi-core processor. Because in multi-core processors, you have multiple registers, multiple cache, and multiple levels of cache. So now I go back and run in 32 mode. 2 seconds later, it's done. I run in 64 mode. 2 seconds later, it is done. Now, of course, the answer is not to put volatile for everything. Because if you put volatile for everything, what will happen? Performance, slow. It'll become very slow. So you got to decide when to make volatile and when not to make volatile. So this requires quite an active effort, but you have to understand the memory model in Java and then be willing to deal with it. So it's a pretty complex problem. What's the next thing you want to talk about? Syntax sugar. 1000, even better. Which of these two is better? It has got to be the second one, because the first one looks too simple to be good. That's what we do, right? Hey, that's simple. It cannot be any good. Both are same. Who says both are the same? You both said. It's even worse than that. I was going to ask you to help to restrain her, right? Well, it turns out in this case, it may not make a huge difference because it's only adding one string every time. That's not a big deal. But actually, if you did the second one, you're doing a disservice. Because in Java 6 and later, when you do a plus, they don't convert it to a string buffer. They convert it into a string builder. So if you do a compile and do a Java P minus C, you will see that it is a string builder. Let's see, real quick. So if I do a single plus, you will notice it's a string builder and not a string buffer. So let's look at an example here. So what I'm going to do here is simply say, let's get rid of this one here. So I'm going to say in here, just a little plus, that's all I'm going to do. So string s1 equals hello, and string s2 equals there. And I'm going to just say, output s1 plus s2. That's all I have, right? So if I go back and look at Java P minus C, sample, so what do you see here? Notice string builder. What's the difference? String buffer synchronizes. How many times do you concatenate string in a multi-threaded situation? That's the right answer. Almost never. If you do, that's a bad idea. Don't do that at home. Right? String buffer is thread safe. But that's unnecessary. You're slowing things down. String builder is not thread safe. And it gives you a better performance for that reason. So it's better to use a string builder than using a string buffer in most of the cases. And it turns out if you just use a plus, it actually uses a string builder instead of using a string buffer. So if you had written the string buffer code, you actually worked against the compiler optimization. You're doing a disservice. So we need to constantly keep up with what kind of optimization happens, because you may have read about something 2 years, 3 years ago, but that may not be valid anymore. And then you may be working against it. So that's something for you to think about. So I hope you enjoyed it. Thank you for your time.